All right, welcome to The Explainer. Today, we are looking at what is honestly a massive architectural paradigm shift in the AI landscape. A brand new paper just dropped on Archive, and it's proposing something called the AI Model Net. It's essentially a blueprint for building an actual internet specifically designed for artificial intelligence models to interconnect, share, and collaborate. If you're tracking the future of machine learning infrastructure, this is an absolutely must-know concept. Okay, let's dive into this. Here's our roadmap for today. We'll start with the AI isolation problem, then enter AI Model Net, look at the three core network mechanisms, do a reality check for developers, and wrap up with the future of AI networks.
Kicking things off with Section 1, the AI isolation problem.
So, to really understand the proposed solution, we first need to look at why the current trajectory of large language models is hitting a bit of a fundamental wall. The immense computational demands of massive monolithic models are forcing a necessary shift in the industry toward lightweight, private, and highly domain-specific variants. The original research paper poses this brilliant thesis. While the primary function of computers lies in computation and processing, the core value of the internet is rooted in sharing and collaboration. Now, what's really interesting about this is how the researchers are drawing a very deliberate historical parallel here. Picture an isolated desktop computer back in the 1980s. Powerful? Sure, but it was fundamentally limited to whatever software happened to be on its local drive. Well, today's AI models are kind of stuck in that exact same pre-1990s state. They're totally isolated. A brilliant medical diagnostic model literally cannot easily ask a specialized legal model for compliance advice. Because they can't effectively leverage each other's strengths, we've created a critical bottleneck, especially as AI workloads are rapidly distributing out across edge devices and the cloud.
Moving right along to Section 2, enter the AI Model Net.
The architectural shift being proposed here is genuinely exciting. It completely flips the script on how we think about model deployment. AI ModelNet is a proposed network architecture that interconnects heterogeneous AI models. Crucially, it treats them as network nodes rather than isolated endpoints. So instead of trying to fine-tune one massive model to just do everything, researchers are proposing direct, standardized pathways between models. They can actually request specific functions from one another and combine outputs dynamically, all without duplicating weights.
And look, this isn't just some pie-in-the-sky thought experiment either. This comes from a highly comprehensive 31-page paper submitted to Archive by lead author Li Zitao and a really robust team of researchers. The paper actually includes 14 incredibly detailed figures mapping out the entire system vision, the hierarchy, and their prototype validations.
Let's move to Section 3, three core network mechanisms, and see how this builds out practically.
So, how does this actually work? Well, the framework basically operates on three primary steps or mechanisms. You've got interconnection, followed by capability sharing, and finally, collaborative reasoning. I want to quickly walk you through this flow so you can see exactly how a task propagates through this kind of network. Step 1 is interconnection. Think of this just like service discovery in your traditional distributed microservices. A new AI model spins up and immediately registers itself on the network. It broadcasts its capability descriptors to the other nodes, effectively saying, hey, here are the functions I excel at, here are my required input and output schemas, and here are my latency constraints.
Once they're interconnected, we hit Mechanism 2, capability sharing. Instead of you, the developer, having to stuff a massive multimodal model into your app, you just utilize the network. A lightweight vision model on an edge device handles the image parsing. It then routes that parsed data over to a specialized reasoning model in the cloud to validate the logic. Finally, a generation model produces the clean output. You route specific functions to specialized peers, which vastly reduces redundant training across the whole ecosystem.
The final piece is collaborative reasoning. This is where the magic really happens for complex logic. The network utilizes defined routing protocols to actually pass intermediate reasoning states between nodes. It breaks down multi-step problem solving and distributes it. This completely eliminates the reliance on a single, massive, monolithic endpoint having to hold the entire context of a complex problem in its head all at once.
All right, Section 4, reality check for developers.
And this brilliantly illustrates what engineers actually need to know before evaluating this framework. If you're a software engineer or a systems architect listening to this, we need to be highly pragmatic for a minute. Right now, if you want multi-model pipelines, you're building them at the application layer, using orchestrators like LangChain or AutoGen. You manage the state logic, AI ModelNet pushes this all the way down to the network level. While that heavily reduces your application coupling, it massively increases your dependency on the health of the model registry and the latency across those physical network nodes.
First off, let's talk operational realities. Remember, this is a research prototype. There are no official SDKs, no plug-and-play APIs, and no managed hosting solutions for this yet. Because the architecture precedes industry standardization, we don't have universal serialization formats or authentication mechanisms in place. If you want to build this today, you are writing custom middleware from scratch. The evaluation metrics right now are strictly directional proofs of concept.
You also have to seriously consider the deployment risks. Model-to-model communication creates incredibly complex new attack surfaces. We're talking about automated node-to-node prompt injection, severe data leakage, and rapid resource exhaustion if a model gets caught in a routing loop. Sandboxed environments, strict rate limiting, and aggressive input validation are absolutely non-negotiable if you're going to experiment with these network pathways.
So the crucial point is coming up in our final section, the future of AI networks.
Despite the current operational hurdles, the prototype validations clearly demonstrate that intermodal pathways drastically reduce redundant computation and significantly improve overall task completion rates compared to isolated pipelines. If you want to see the exact architectural diagrams, explore the routing protocols, and dig into the prototype code references for yourself, look up AI Model Network Concept, Current State and Future on Archive under identifier 2606.27382. It is a fantastic, highly detailed read that will absolutely put you ahead of the curve on infrastructure design.
I want to leave you with this question to ponder. Is AI ModelNet the inevitable internet of artificial intelligence? You know, just as standalone computers eventually had to network together to unlock their true potential, it seems almost undeniable that AI models must undergo that exact same evolution. We are quite literally watching the transition from isolated monolithic models to a collaborative global network right before our eyes. Thanks so much for joining me on this explainer, and I'll catch you on the next one.